Well, good morning, guys. I got out here about 6 o'clock getting some wood ready to stabilize with Mesquite Man Cactus Juice Stabilizing Resin. www.turntex.com. That's where I get it. It's a heat cured stabilizing resin. Works awesome. I've got a box about 20 pounds worth of already stabilized spalted oak. I'm going to show you my methods. That's my gallon I just got yesterday. It comes with a bottle of catalyst that you've got to catalyze yourself. It's a very simple, straightforward process. Anyway, my chambers that I use for my small pieces of wood that I've got over here, that's all oak. Well, most of it's oak. The ones that are cut back here were cut off a piece of hickory that a tornado twisted off in 2010. But I've got a couple of small vacuum chambers built. This one that's about 3/8 inch plastic cutting board material that I got. It was a bigger sheet. I cut it in half. This is 6-inch Schedule 120 water pipe. I scavenged from a site where they were doing some water line repairs. And basically that is a neoprene Buna N and vinyl combination seal that I screwed to the bottom because the silicone I was using was starting to fail. But on the bottom, you see I've got 8, those are deck screws that are countersunk into the bottom. What I did is I marked the circumference, the inner and outer circumference of the pipe on one side, and then I went in the center of those 2 lines and drilled 8 holes, about equally spaced apart. Drilled the holes in there, countersunk them, set the pipe on it, down on the floor, put the cutting board on top of it, got it as lined up as I could. I put some witness marks on it to get it lined up, drilled some pilot holes through the pipe, then of course ran the screws through the cutting board, the foam material, and into the pipe. If you try this, you have to pre-drill the pipe. If you don't pre-drill it, it's going to crack out on you and you're going to have a useless piece of pipe. The other one I've got here that the cactus juice is setting on, it's the same kind of pipe, but it's got a 1-inch clear like sand bottom. I tried to use that as a lid, put silicone in it, thought it was dry, pulled a vacuum on it, had a different base on it, pulled a vacuum on it, it was permanently attached. So I took the base off, sealed it up real good, and used it. And inside of these, I use cut down margin containers. These are for my smaller pieces that I do. Smaller pieces get little cheesy weights like this. I need to make some better weights, but I've got some smaller weights. Got a heavier weight if I need it. And over here, these I just cut this morning off of a limb I cut about a week ago. I don't know if you can pick up the spalting on there. They have excellent spalting. Some of them are so punky, like this one here weighs 1.2 ounces. I mean, it's so punky you can flake it off with your fingers. This wood is going to go down in this pressure pot. It's a cheap PSI paint pressure pot, 60 PSI max. I'll put them in there. Since I've got so many, I'm probably going to have to double layer them. And I've got good heavy weights for those, for that container right here. Get that out of the way. That's expanded steel with 4 or 5 inch sections of 5/8 inch steel on it. Here's a separator plate. I'm going to put a layer down, put the plate over it, put another layer on top of that, put the weights on it, and I'm probably going to give it about 1.5 inches, 2 inches of juice over the top, because being as punky as they are, probably going to soak up a lot of the juice. Now on some of these, they are cracked already. This thing won't give a very clear picture zoomed in. Some of them are cracked already, and they started cracking when I cut them last week. That's why I waited until today to go ahead and cut them down on the bandsaw, because as soon as you cut them, they need to go in juice. Limbwood is extremely unstable, and I love working with limbwood. It's unstable because the way the limb grows horizontal from the tree, you've got compressed and relaxed growth rings. As soon as you cut it, you start relieving the tension on those stretched growth rings, and it wants to crack. But I'm going to start the process. I do not use a rotary vane vacuum pump or anything like that. Nothing with a continuous run. What I use is compressed air at about 60 to 70 psi, and I use vacuum generators. That's air vac pump 062H vacuum generator. It gets down to about 27.5 inches as advertised. I've got it down to 29 inches before. I pull a real hard vacuum with those. I've got another one down here for this pot. I also use them for vacuum chucking, but they've got ball valves on them so I can control the flow if I need to. And the lids for these containers over here are clear Lexan, about 1 inch thick. Each one has a gauge, a ball valve to shut it off when I get the vacuum on it. I've got a QD fitting if I need to take it off for any reason, which I don't need to now because I have a 3-way manifold. That old compressor I had died on me, so I cannibalized it, made a 3-way manifold, and the new compressor I've got to replace the old one. I know I had a video of it before, but I don't think you saw it. Turn the light on. That's my pride and joy now right there. Cobalt 30-gallon twin cylinder belt drive air compressor. I've already tested it. It will drive both of those vacuum generators, because they use, I believe, 0.82 CFM on those. Anyway, I'm going to go ahead and get these situated in here and get them started. This will probably be a multi-part video, just, you know, what it is now. Then I'll do a short video during the process showing you the vacuum, letting you see the vacuum gauges, what kind of vacuum I attain. Then afterwards, what they look like coming out. All of these pieces I've weighed on a digital kitchen scale because I want to compare the weights to them when they come out. Those are going to go through probably 2 to 3 hours of vacuum and probably 4 hours of pressure at 50 psi, just so I can make sure I get them very well juiced up. But I'll back in a little bit and show you all the process.